Welcome, everybody. We're going to be working on the Unit 4 exercises tonight, which focus on loops. As part of our Kahoot and kind of like precursory lecture, we were talking about different IDEs that you can use to code in Python. And one that's really notable and arguably very important for people who are especially in data analytics, data science, AI development, machine learning, and other similar areas is a tool called the Jupyter Notebook. The Jupyter Notebook basically is a standalone product. It is included in the Anaconda distribution, but it is notable to say that you can go directly to their website and download it directly if you wish. I don't usually do that. I usually use the one that's built into Anaconda. And the Jupyter Notebook operates in kind of an interesting fashion. It doesn't create straight Python files. It creates what we call Python notebook files, which are collections of little snippets of Python programs. It intersperses Python code with Python code output and allows you to insert Markdown, which is basically text and graphics and links and illustrations, for example, within your document, and then save it all as one file and deliver basically many programs in one file with explanations about what all of it is, right? For whatever reason, this is the tool of choice for particularly people in the data analytics areas. Notable to say that there's alternates to this. For example, I used to use Jupyter Notebook when I did a lot of the AI and data stuff, and I've been finding myself using Visual Studio Code. I like the interface better and a couple of the other tools that are in there. So you can do Python notebooks inside that product. There's also PyCharm, which we talked about from JetBrains, which does a great job of it, and the full-blown Visual Studio as opposed to the lightweight Visual Studio Code product. I'm going to go ahead and jump into Anaconda. The navigator is up and running on my screen here. And I'm going to go ahead and click the launch button for the Jupyter Notebook. That should be already installed on your machine if you installed Anaconda. It's one of the default IDEs. Spider is default and Jupyter Notebook is default. What's kind of interesting about Jupyter Notebook as I launch it, it'll take a moment to launch, is that when it launches inside of a browser window. So the environment is canned inside a space like that. And of course, on my screen, it's opening on the other screen, but I'm going to pull the tab open here. And I'm hoping it's running. There it goes. And when you land in the product initially, what it does is it drops you into the root of your user folder. There's this new sidebar that they've added that I'm not really kind of a huge fan of, by the way. But it is there, and I should probably experiment with it a little bit. But we are going to basically look at like how it stores its files and then where we put things. Now, the location where these notebooks get stored, I do want to bring up a file window here just so you can see where this is it lands you in the root of your user account on the C drive in Windows. It does the same thing on the Mac, if I'm not mistaken. It's been a while since I've used the product on a Mac. But when you store your notebook files, it by default puts them here, which guess what, is not the normal place where we put stuff. You can, through this interface, get to your documents folder where a lot of people do store their things, and then you could come up with like a Jupyter folder, for example, and then put your stuff in there. That's on you, though. If you are going to run code inside the Jupyter Notebook, just be mindful of where it puts stuff. So if you come back later and you're looking for it, you can find it. And it's really kind of the goal here. I'm going to close the sidebar, and then what I'm going to do is I'm going to come up here and I'm going to click on the new, right, Python 3. You notice that in some cases, we do have alternate environments that we can go into. And this goes down a whole deep rabbit hole. And my AI people know what I'm talking about, right? Because we can have virtual environments, and then we can create custom environments and all that kind of goofy stuff. But I'm just going to use a regular Python 3 kernel, right? So we're running on top of the regular installation of Python here on the machine. I'm once again going to close this little sidebar, if it lets me, it looks like it wants to be persistent, which I'm not liking. There we go. All right. Now, as I land inside here, you'll notice that it kind of brings up a little bit of a weird interface. The first thing I will tell you is that these windows here that you see, we refer to these as cells, right? And each cell is capable of containing a Python program that will execute independently of other cells in the same notebook. So for example, I can just write a really simple program like print, hello, whatever, something like that, right? Just write a regular Python program. And then once you have your code entered, you can hit the run button and it will run whatever cell has this highlight here, basically the one that we're in right now. And I will run it, and then you'll see that it outputs code right there, right below. And now it's created a brand new cell that's ready to receive additional Python code. Now, what's kind of neat about this is I can run a program, I can see its output, I can adjust it, run it again, or do variations of it, or run a bunch of different programs at the same time. So one of the reasons I'm doing this is because when we look at our first exercise, you will notice that it's a multi-part exercise. So I'm trying to kind of address that issue a little bit in the process of doing this. We are going to start with exercise 4.1. And I'm going to, somewhere here on my screen, I do have these exercises kind of already brought up so we can look at it. But you notice how this has multiple parts. So one way you could do this is you could basically write an individual program for each one, or you could write all the programs into one file and run them all together if you wish. But you notice how there's a bunch of tasks here to complete. All of these revolve around looping. So in the process of like solving the problem, we're going to learn about loops at the same time. So the first directive is write programs with loops that compute the following. And what I'm going to do is I'm going to grab that first one, which is basically the sum of all even numbers between 2 and 100 inclusive, meaning we're including the number 100 in the process. Okay, so I'm going to jump over to the Jupyter Notebook and I'm going to first drop in, I've got this apparently pre-coded here, right? I'm going to drop in this little snippet to get us started, right? So this is just the directive. So exercise 4.1 part A. And now I'm going to start writing the code. Okay, so one thing that we sometimes do, and this is, I'm going to tell you right up front, the first bit of code that I'm typing is actually not necessary, and I'll prove that later. But if I want to get the sum of all numbers, it might not be a bad idea to create a variable that's going to hold the answer, and I'll just call that total, and I'll preset it to 0. Right? And, you know, I'll put in this little comment because we are going to use it to store all the values. But we don't actually have to pre-declare it. And this is kind of weird about Python, right? I could just throw this in the loop and it'll just create itself. But I do this more because of my practice of like other coding. And then some people think this way too. So one of the reasons I do it. Now, the type of loop that we're being asked to create here is one that we can hard code using a for loop. So I'm going to kind of use the same stuff we were learning about a little bit earlier tonight, which is to say for I in range, and then we are going to use the range command to trigger the loop to do the math, right? Now, I want you to think about this with all the stuff that we've learned, right? We learned that the range command, like if I did like for I in range from 1 to 10, right? And I'm going to go ahead and code this through as, this is an example. This is not the answer, by the way. And we were just to do a print of the variable, right? And I run this. So let me go ahead and run this, right? We start at the number 1. Every time it goes through, it increments by 1. It adds 1 to I, and then it prints it, and then loops again. It counts up to 10. By the time it reaches 10, it jumps out. It never prints 10 because 10 is the trigger number to pull it up. Okay, so that's just to remind you how that works. I don't know if you guys remember, we can add a third parameter, which is how much we're counting up by. So if I ran it like this, notice I have 1, 3, 5, 7, 9. Remember the Kahoot question? Basically the same thing. Yeah, absolutely. So if I wanted to get the sum of all even numbers between 2 and 100, what should I put in the box here? All right, so this is what your answer should be. You should start with the number 2, right? And then we would count up. We want to include 100, so we have to go at least one beyond it. So we would go from 2 to 101, counting up by twos. Now, we don't want to print those, but I'm going to run the print command just so you can see that it does it, even though it's kind of a long list. And you notice how fast it did it? Very, very fast. All right, so now we don't want a print statement. We want it to do some math. So what I really want to do is I want to take that total variable, and every time we go through, I want to add to it the value of I currently. First time through, it'll put 2 in there. Second time through, what will the value be? Well, now it's going to take 4 and add it to 2, so we'll have 6, right? And then it's going to add 6 to 6, and we'll have 12, right? So that should be kind of the pattern.
What does that plus equal do again?
Plus, okay, so thank you for saying that, Kathleen. So plus equal kind of the same as saying take whatever's in total and add I to it, right? So like this would be the alternate way to say the same thing. Whatever's in total right now, add the value of I. And this is a programmer's shortcut, right? We do plus equals, which just takes whatever is in I and adds it to total rather than having to say total plus I.
Okay, got it. Thank you.
You're welcome. All right. Now we can run this. Now this is kind of interesting. If I run this and I'm just going to do it, right? It ran. There's no errors. But we don't know what the output is, right? Because we don't have an output statement in there. So here's kind of an interesting thing to do is to see what the total is, right? And I have some pre-configured code here, so I'm just going to use it if you guys don't mind. Right, here's an output statement. So I can run this and it'll tell me what the total is. Now I know that's correct. Again, ask me why, because I've done this before, right? And I did once throw it into a spreadsheet to verify it. And that's kind of like another thing that you can do is you can verify your math in a spreadsheet. And normally I would tell you, please do that. But it doesn't really show us the progression of the numbers adding up. So what another thing that you could do here is inside the loop, you could print the value of total each time it goes through the loop to get to that value of 2550. So watch what happens here, right? So went from 2 to 6 to 12, just like I told you, right? And then it just keeps adding up and it gets up to 2550. But if I put a print statement inside there, I can see it. I could also print the value of I and the total, along the way. So you can do whatever you want. I would say this is not really necessary because what we're looking for ultimately is actually just the sum of all the even numbers between 2 and 100 inclusive. All right, let's move on to the next one. This is part B. So I'm going to a new cell. Now, I want you to think about what's going to happen here as I type more code. When I go to run the code in cell number 2 or whatever they're going to call this, it will not interfere with the stuff I've done before. This stuff will stay on the screen, the code and the output. Right. So the directive on this one is the sum of all squares between 1 and 100 inclusive. All right. So what the heck do they mean by that? All right. Once again, I'm going to start with a for loop on this. So let's do for I in range. And we're going to have to put stuff inside the parentheses here. Where are we going? We're going from 1 to 100. Do I have to count by twos this time? Nope. So we're just going to say 1 comma, but we want to go to 100, so we got to go to 101, 1 past 100. Put in a colon here at the end like we do for an if statement. Notice how we're indented. And then we'll say the total plus equals I squared. So the first time it'll square a 1, the total will be 1. The second time it'll square 2, the total will be 5, right? And normally, I would have a print statement at the end, and that's where we're going to leave it. But once again, I might encourage you, if you wanted, to put a print statement inside here so you can see the total increment along the way. And if you wanted, you could get a lot fancier with it. You could say the current value of I is, I squared is, I added to the total is. You could like type all that in there, but that's not really my goal. I'll leave this in there for now. Let's take a look at how this operates, right? And notice how quickly that number climbs, right? Why? Okay, so this is really weird. Why the heck did it start at 2551? Okay, think about this for a second. Total was a variable that we started up here. And so that actually maintained its value from finishing the first loop. And then when I started the second loop, even though I was in a different cell, the variables from the previous cell still held their value and now are affecting the other program. So this is kind of an explanation as to why I was setting total equal to 0. So when I run the code again, we start from scratch. And I'll notice the difference in the output as I run it. Wait, got to be in the cell. There, okay, there we go. All right. Now notice the number still gets large, but now it's starting with 1. And then 2 squared plus 1 is 5. And then it goes on up. And that number gets really big pretty fast too. But ultimately, the correct answer is this. This is what we're looking for. And once again, this print statement here is superfluous, but I think it's kind of neat to be able to see what it's doing in the background. So ultimately, I'm really looking for that answer. That's part B. I'm going to move on to part C. And we are going to take a break here pretty soon if you're getting antsy. I just want to get some of this done before we move on. So for part C, the directive is we need all the powers of 2 from 2 to the 0 up to 2 to the 20th. It's not asking for a total. We just want to see what those numbers are. See the difference there? Once again, we are going to use a for loop. We'll still do an I in range. And then inside here, we're going to go from 2. We want all the powers of 2 from 0 to 20. So the range here, I'm going to start with the number 0 because the thing I'm going to control is the power, because the 2 is not going to change. Just the powers are going to change, right? So we're going to take the range from 0, but we want to go to 20, so we go to 21, 1 past it. We put it in our colon, and then we can go right directly to output if you wish. So I'll do a print statement, and then let's make this an F string this time. And then I'll say 2 star star, and I want you to notice what I'm doing here is I'm going to put in the value of I. So I'm going to say like 2 to the 0 power, 2 to the 1 power, right? Is, or I could do equals, whatever. And then I can actually just do the math inside of here, which is 2 to star star to the I power. And then that will just be inside the string, right? Is that a curly bracket? Sure was. Okay. And then we want to close that like so. So combining kind of a little bit of verbal output with an actual calculation here. Here's the runtime on this. So here's all the powers of 2 from the 0 power all the way up to the 20th power. And there's all the code for this one. This is part C. you're not sure those numbers are correct, you can also put it in a spreadsheet or a calculator and figure it out. Um, as a really nerdy side comment, I can look at that list and I can get all the way up to at least this one. And I have all those numbers memorized, by the way, right? Because if you've been in IT for a while, you see like these patterns. People who were in the database class earlier today, you recognize that number, right? From like the size of some of the data types and what they would hold. So these correlations, and it's all because of binary extrapolation, by the way. All right, let's move on to part D. And once again, we will take a break soon, so just hang tight, folks. This one says we need the sum of all odd numbers between A and B inclusive, where A and B are input. So in other words, we're going to prompt our user to enter those values. All right, I do have some pre-configured prompts that I'm going to drop in. So I'm prompting the user, enter an integer, convert it to an integer, store it in A. Enter another integer, store it in B, right? So those are the prompts. Now, this is kind of an interesting little thing I'm throwing in here, and this is for your consideration before we do the calculation. And I say, if A is even, then the first number we want to include in the total is A plus 1. So here's the thing. I don't know what numbers the user is going to type. So what this is saying is I got to check to see if it's even or odd, right? Because we need the sum of all numbers between A and B, but the sum of all odd numbers, not the even ones. So this is kind of like a weird ask. So if they put in an odd number first, we're fine. We can start with that. If they put in an odd number second, we have to add to it to make it so that it's an odd number so that we can work with it. All right. So we have to write a little snippet of code to test this first. And so here's what I came up with. If A mod 2, right, we're dividing by 2, is equivalent to 0, what does that tell us? It's an even number. If we divide a number by 2 and it has no remainder, that's what that's asking. That means it is an even number. So in that case, given the logic I've explained here, we want to start counting odd numbers, not even ones. I would take that first number, I'm just coming up with a variable called num1, and I'm going to add 1 to it. I'm going to take A, add 1 to it. Now it's an odd number. So I can start with that in a loop. Else, the first number will basically just be the number that was fed in. I don't need to alter it. And really, now that I think about this code, I probably don't need the else, do I? Yeah, I kind of don't. But, oh no, it depends on how I set up my loop. I shouldn't say that, right? So you'll see the logic here as I kind of move forward. So with this one, now we're going to use a loop basically to generate the odd numbers from A to B inclusive, adding each to the total. So we're doing this dynamically because once again, I don't know what the user is typing in. I'm going to preset my total variable back to 0, right? If I didn't have the other cells, I wouldn't have to do that, by the way. And then I'm going to go to a for loop again, and I'm going to say I in range. And we're going to start the range at the first number, the one that they either typed in as an odd number or we added 1 to it to make it an odd number, right? So we start at the right point. And then we want to go from A to B, which we're assuming is a larger number, right? And I should probably put that in the prompt, honestly. Enter another integer that is larger. That's probably a better prompt. All right. So if I want to run that up to the other number, which is the other number, first of all, it's going to be a variable called B. So here in this position, I would go to B, but we know that the range command requires us to go 1 beyond, so I have to add 1 to it. Right. And then we're only going to do the odd numbers. And since I converted the first number to an odd number if it wasn't. Now I can increment by 2 and it'll skip over all the even numbers. Isn't that a clever little algorithm? Yeah, it sure is. All right. And then all we're doing here is totaling, adding I to the total each time through. And then ultimately, we'll output that to the screen. And I have this print statement kind of like in the pre-F string format for strings, but I'm going to convert it to F string just to show you guys how easy it is to do that. Just basically put curly brackets around things. And then you can see why F strings are a little bit easier. Oops, should not have deleted all that. This is how you would convert it to string. All right. Now, in order to really kind of figure this out, what I recommend is that you use numbers that are really easy to calculate. So don't use like some ridiculously huge integer. Use some small numbers so you can calculate it in your head. So let's go ahead and run this. And here's the prompt here. Enter an integer. I'll put in the number 1. Okay. Starting with an odd number. I'm going to enter another integer that's larger. Let's just put in the number 3. It's a little bit larger, right? So the total of the odd numbers from 1 to 3 is 4. That's correct. All right. Let's run it again. This time, let's put in a 2 to start with. And this time, let's go to 5. Okay, so think about this. It'll add 1 to 2. So then it'll count 3. It'll skip over 4, go to 5. So we got 8. And then we're done, right? Okay, so it seems like the algorithm is working. And then if you want, right, you can get really silly and put in some large number like that. And then it will calculate it. Now, are some of you waiting for this loop to finish? Is there anybody here coding along with me? Is there a loop taking a little while to execute? I don't think this has failed. I think I'm still waiting for an answer is what's going on. Yeah, so Wayne, did you get an answer on yours? I assume the yes is a yes. All right, I guess I'm still waiting. I'm not seeing the output. Right. I do this sometimes where I do run some algorithms on purpose that take a while to execute. And yeah, it's kind of funny. I kind of anticipated an answer already on this one, so I'm not really sure what's going on there. So if it like an answer pops up soon, I guess maybe I shouldn't use numbers that are quite so big. So let's try running this again. And I think it's still trying to run. Right. So here's one little tip. It seems like I pushed it a little too far. You can always restart your kernel. Yeah, it says it's busy, but it is possible to restart the kernel. So I'm going to do that. This is something we haven't done in this class yet. And okay, it's restarted. Now I should be able to run this cell again. All right, so let's try it with not quite so large numbers. Maybe that's a good one. And then we'll go up to this. All right, and that one it did pretty quickly. So I think I was maybe pushing it a little too far. The other possibility is I might have been overflowing what an integer can hold. That's a whole separate issue. Normally that doesn't happen though. All right, so that's a completed run. I think we have one more part here to do and then we'll take our break. This one hopefully shouldn't take quite as long. And here's our directive. The sum of all odd digits of an input. So in other words, if I type like a 5-digit number, like this, 3267, it would read through the numbers, find the ones that are odd numbers, and just total those. Now, I want you to think about this really carefully. When we do input from the keyboard, which we have to get from our user, by the way, we would ask them to enter an integer, but notice I'm not converting it to an integer. I'm leaving it as text. This is a strategy. The strategy is that when something comes in as a string we've learned is really a complex data structure that has individual characters. I can traverse those individual characters by doing leaving it as a string. I will preset my total variable because that's where we're going to store stuff. And then we're going to do our first, what I call a for each loop, which is a loop that automatically traverses a data structure. So in other words, and it's very typical to do this, by the way, when we're traversing a string, that we'll use a loop control variable named ch for character, basically. So for each character in digit, so if I type 3267 as text, this loop would traverse each character one at a time every time it goes through the loop, right? So for each character in digits, do the following, right? The first thing we're going to do is we'll set up a variable called n that will convert the character to a number, right? Because we still want to do math with it, but we're waiting until here to do it. This is kind of a interesting little thought. Then it says we only want to do the math with the odd digits, and we got this little snippet of code basically from our Kahoot earlier, that if we mod a number by 2 and it equals 0, it's even, but we're looking for the odd one. So if the remainder is 1, it's an odd number. Then we'll do the math. So then we'll say total plus equals n. So it'll only add it if it's an odd number. If it's even, it'll just skip over it, right? Then, of course, we want to put that on the screen. So we would do a print. And last time I did this, number being added. And let's make this an F string before I forget. I sometimes do that. So we'll just put n in there so we can see what number we're adding. And then we can also say, and if you want, you can put a comma after it and say current sum or total, if whatever you want to put in there, and then we'll show what the total is currently. And so every time we hit an odd number in the number that we enter as a string, it'll show us which number that is and what the current total is. And then, you know, if you wish, you can also just print the total down here. And what I did last time is I did this print statement here. And I never closed this with a double quote, so that's why it's highlighting red. If you want to convert this one to an F string, just put an F there. Like so. Okay, let's run it so you can see what it does. So enter an integer. We're just going to type a kind of a long number. If you want, you could pre-add them, you know, if you wish. I'm not going to, right? So, but it says the current number being added is 1, 1, 3, 1, 9, 7, 5, 1. That's right. That's all the odd numbers. Shows you the current sum and then gives you the, you know, the total of the odd digits is 28. All right. Let's go ahead and take a break, folks. So I'm going to pause the video and we'll do a 5-minute break. All right, now that we're back from break, I wanted to point out a couple things about the Jupyter Notebook as we press forward here so you guys are aware. The first thing that I did is I came up here to the title area or the header area of the page, and I renamed my exercises Unit 4 exercises and hit rename. The other thing you can do is at any point, you can save the notebook and choose a file name for it and put it wherever you deem appropriate. The one limitation, though, of that is it does end up in that users folder inside of Windows, and it doesn't really give you an option to go somewhere else, by the way. So that's on a C drive, users, whatever your user account name is, and it just drops it right here in the root. Not really, I'm going to say, the best storage technique. So the file I just created is this one here. I want you to also take a look at the file extension on this one. The file extension is IPYNB. So technically it stands for IPython Notebook. And that format, excuse me, is openable by other programs, including programs like Visual Studio Code. And I'm going to see if I can bring Visual Studio Code over to the screen here. And then I'm going to go ahead and open up one of my notebooks that comes from one of my classes here. Some of you might happen to be in there, but I just want to show you like some of the stuff that can be inside of a Python notebook. And I want you to notice that aside from code, there's also text, and it looks like a document, right? So this is kind of why they do this. So this is one of the labs that we do in the natural language processing class. So we talk about the libraries that we're using. They have examples of visualizations. They talk about like word clouds and whatnot. And then you have the coding cells. And if you want to operate a cell, you just hit the play button right here. But essentially it works just like the Jupyter Notebook. So I have cells where I can run code, and then I would see the output from the code. So like, for example, when I run this code here, it generates this image, this word cloud image, just for example, right? The other thing that I think is kind of interesting here, and I do have to bring back my file that I was just looking at, which is this one. That's my cheat sheet, by the way. And when you're inside Jupyter Notebook, I want you to notice that when you move to a new cell, that by default, the cell is set to receive code. You can also flip this little switch here and turn it into what we call markdown. So this cell now will just accept text. So I can just write words here, or drop in a graphic, or put in a web link, or, and you can go on, and you can format it and bold and big letters and small letters and whatever. But I think it's kind of interesting. What might be more of a pertinent thing to do really is maybe put in the next exercise description in the form of markdown. So I grabbed this from the document. That is, if I can extract it here. Let's see if I can just drop that in here. All right. So this is just markdown. And then since I'm done with my markdown, this is all the problems we're about to work on. Notice here that they have these little things: insert cell above, insert cell below. So I'm inserting a cell below. By default, it becomes code. If I want it to be markdown, I can do that, but I'm not, so I have my text here. And yes, I can go back and edit this and do whatever I want to it, right? I can make the fonts bigger, whatever. I'm not really too worried about that right now. Let's just get the next exercise going. And like the previous set of exercises, this is a multi-parter. So this is part A. And we will get to the point where I might start, just to accelerate our workflow a little bit, I might share some snippets of code with you just so we're working a little faster, by the way. But the first one is read the first input value from the user, right? And then the question is, if the first value was an integer, process it, and then the remaining input values. Otherwise, an appropriate error message is displayed. Now, where these instructions come from is basically part A above. So like what we're doing is the smallest. So read a sequence of integer input. So we will prompt the user to enter an integer, and then they can just keep entering numbers until we make them stop. Is basically the point. And then based upon that, we want the smallest number and the largest number out of the inputs. Think about like what mechanics we have to do here. So let's first, and that's why this comment is what it is, read the first input value from the user. So before we loop this, I'm just going to prompt the user for a value. And notice I'm not converting it to a number quite yet, right? I'm just grabbing it. And then I'm also giving them a directive that if they don't want to run this program anymore, just don't type anything in and just press enter a blank line to quit, right? So when we get into running our loop, our sentinel value, because we're going to do a while loop this time, that we're looking for is nothing. We're just looking for a blank entry. All right. So then we have this little bit of logic, and if you guys don't want to get all like falling behind here, here's my kindness of the night. This is the code I've typed so far. You can just copy it. And so the first thing that we're going to ask here is if the first value was an integer, process it. So let's just, do something with it. And then the remaining input value. So we're assuming they're going to type more. Otherwise, put an error message on the screen. So if they don't like respond appropriately, we want to respond to that. Okay, so let's think about the logic here, because we're going to let them input a series of numbers, and we're going to find the smallest number and the largest number. But before we do that, let's make sure they didn't type a blank line. All right, so let's just put in an if statement that says, if the input, spell it right, string, which I typed str, does not equal a blank, so just empty double quotes, then we're going to run this code. We're going to say, create a variable called value. And what are we going to put in there? We're going to take that input string and we're converting it to an integer. So then we can process it as a number once again. Then we have to figure out what the smallest value is and what the largest value is. You know what? The first number they type in is both the biggest and the smallest. So check out this clever little hack here. So the smallest equals the value and the largest equals the value. All right. We're still inside the if statement. So I'm going to move on down here and I'm going to indent, and then I'm going to add this little snippet here to describe what we're doing next. Right. So it says, as long as the user hasn't entered a blank line, convert the input to an integer and determine if it is a new smallest or largest value, then go into the loop and do it again. Right. So here's where our loop starts. So the loop is inside of an if statement. So while the input string does not equal a blank, we're going to do the same thing. We're basically repeating this line. We're converting whatever the value is. Oh, yeah, I did. Thank you for pointing that out, Madeline. Whatever the value is, we're converting the string to a value so we can process it. Then we can check if the value is less than the smallest number. Well, then the new value is smallest, right? So we'll take the value, put it into smallest. If this number is smaller than the previous, we're storing it. All right. Is there an else to that? There isn't, right? But we're also going to test the same thing with largest. We're just switching the sign, spelling it correctly, by the way. And then we'll say if that value is bigger than the largest, then that gets stored into largest from now on. So that's how we're keeping track of it. Then at the end of the loop, right, we're going to repeat our prompt. So, and then check out kind of the cleverness of this, right? So we go through the process, we get a number. As long as they didn't type a blank, because they might have done it right from the beginning, we'll take whatever number they typed, turn it into a number, store it in smallest and largest. Then we go into our loop. We know that the input string was the first time it'll run for sure, right? Because if it clears this if statement, the while loop will also run, right? We do the conversion again. Don't really need to, I guess, but do the conversion again. Check for smallest, check for largest, and then prompt them. And this will keep running as long as they're typing numbers. The moment they decide to exit the loop, we just type a blank line and we're out. So that's how we proceed through the loop. Now, I'm going to come out of the loop now, but I am going to come back in, and I really want to be at the same level with the while loop. So not with the indent of the while loop, but back one layer there. And then we're going to show the output. We're going to say, display the results, and I'm going to move this down the line, I guess, right there. Show the output. And I do have a pre-configured print statement. It's not an F string, by the way. You can convert it to an F string if you want. And then at the end of it all, tell us the smallest and the largest. Okay, but what if the condition up here isn't true? They didn't type a value. Then this if statement up here, I'm going to come down here and put in an else way down here. And then I'm going to put in an error message. So if they didn't type a value at all, right off the bat, no input values were provided. I'm just putting a message on the screen just to verify that they didn't type anything in, right? Right. And then, let's also let them know that this program is over, and you might want to put a message on the screen that's maybe like program complete. Kind of thinking like that Star Trek voice, program complete. And that's the whole program, folks. All right. I am going to go ahead and run this. And I know you guys are like, can you share the code? All right. So I'm going to share this code. I'm not going to do this for all the programs, by the way, but I know you guys are probably trying to hustle to keep up. Remember that you can go back to the videos, and I have videos from previous years too that you can copy from. The important thing is to get it to work, and all your indents are right and your logic is all correct. So let's go ahead and run this. Here's the runtime, right? So enter an integer, type in a 1, 2, 3, a 4, a 5, a 6, 7, 8, a 9. Now, why am I typing those? Because I'll remember them and I can tell really easily which one's biggest and smallest, right? And then this one's blank, so I'm just going to press enter. And then it stopped. And then it said the smallest value is 1, the largest value is 9, program complete. Now I can run it again and not type any value. I notice it says no input values were provided, program complete. And as long as I did it again. And this time I'm going to type in a number. I'm typing in the same one. That's kind of boring. And I just want you to notice that it'll just keep going, 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 and going. And it won't stop until I type in a blank line. Now, I want you to think about this a little bit, right? This is a weird algorithm because we want them to input something and we're trying to compute like which is the biggest and smallest. But this loop algorithm is one that you could wrap around any program that you've written here in this Python class and keep the program running until the user decides to exit. So I'll show you a technique for that. And I was thinking I'd make an extra credit assignment out of that too, but I'll show you some code. Right now I'm trying to get through the exercises, so let's just keep plowing on this because this is just the first part of 4.2. So there's a 4.2b. 4.2 is the number of even and odd inputs. So we're still going to use the same prompt. So this is what I'm putting in the chat here. I'm just trying to help accelerate your workflow a little bit. Right, so this is what I'm starting with. So I'm using the same prompt as I did last time, right? Since we are, what was the directive? How many evens we have and how many odds we have, basically. Now we're going to run our while loop, and I just want you to notice this is the same while logic that we had before. As long as they don't type a blank line, the loop will run. We'll do the same conversion of taking the string and turning it into a number, storing it in value, and then we'll check to see if it's odd or even. We kind of know the code for this already. So if the value mod 2 has a remainder of 0, it's even. So I'm adding 1 to even. We're just counting it. Otherwise, it has to be odd. It can only be one or the other. So I add 1 to odd, right? And then I will reprompt with the original prompt. Back one level here. And that will keep running until they decide to type a blank line. And then at the very end, we need a little print statement that tells us how many evens we had and how many odds we have. All right. So you guys have to type some of it. There's the first part. There's the second part. By the way, this is why it pays to come to class, right? Teacher's giving me the code in the chat. All right, let's run it. All right. And I'm just going to type simple numbers here just to make it easy. Just counting down from 9, going across the top of my keyboard, and there's a blank line. The user entered 4 even values and 5 odd values, and that is correct. All right, so that was part B. Now we're going to follow a lot of the same coding structure because all of these involve the user entering information and then waiting for a blank line. The next directive is cumulative totals. For example, if the input is 1, 7, 2, 9, the program should print 1, 8, 10, 19. So every time we add a number, we're going to display it. Once again, here's the opening statement. So this is 4.2C. So once again, asking for an integer, blank line to quit, take our total thing because we're going to be storing a total and setting it to 0 to wipe out the previous settings for it. We're going to run the same beginning to the while loop. You already have this code, so that's why I'm okay kind of putting it in the chat. This is the same code again. And then we'll take here the total and add to it the value currently. And then we'll display it. And then we will reprompt. And then when we're done, if you want to be snarky or just polite or whatever you want to call it, you know, with command line programs, sometimes it's kind of nice to let the user know, hey, this program's done. It also shows you that you're out of the loop, right? If you're not picking up on that. All right, going ahead and running it, right? So then you can make sure that the math is right. It's really easy to make sure the math is right with really simple numbers. And then once you know it's working with simple numbers, it must be working for the bigger numbers also. So that's 4.2C. All right. Once again, let's look at what our directive is here. So I'm going back up to the directions. For part D, all adjacent duplicates. For example, if the input is 1, 3, 3, 4, 5, 5, 6, 6, 6, 2, the program should print 3, 5, and 6. So any of the numbers that repeat in the sequence would be displayed. Kind of an interesting little dilemma here. So this is part D. We are going to start with this code. So in the chat. So once again, same prompt, by the way. But we're going to keep a new variable where we take the input string and we store what we have. So what are we doing here? When they type in a number, we're going to store the number they just typed. So when they type in the next number, we can compare them and see if they're the same. See the thinking? And then I'm also going to set a Boolean variable. I think this is the first time we're using one in a program, I guess officially. And I'm setting it to false, meaning I want to see if I printed it to the screen already. So like in other words, if I type 3 and then I type 3, well, this should put the 3 up on the screen. And then I type 3 again, was it printed? And if it's already set to true, I don't want to put the 3 up again because it's still repeating. See the logic there? So I'm setting that to false, and then we'll trigger things. Now, we'll start with the same while loop opening. So you can just grab this from your previous code. Now keep in mind, we've already grabbed the information, stored what they grabbed in previous. So now I can prompt them again right now. So I'm just copying my prompt and asking for another value. Now we start to do our logical check. So here's the first logical check. This one I'm dropping in the chat, by the way. So with this one, if the previous number we captured is the same as the input string and the printed is set to false, I will print the number on the screen and say 3 is a duplicate. And then I'll switch printed from false to true. So just in case they type that number again, I don't have to repeat the message. You see the logic there? Both of these must be true to print that information on the screen. All right. Is there an else to this? There is not. But there is another if. Here's the other if, and then kind of the closer here, which is if the previous value does not equal this number, then we reset printed to false so we can start again and then catch the next number that repeats. And then we'll take the previous one and capture the previous input string here, kind of repeating our process up there. But first we do the checks. All right, let's run this. There's no additional code. That's all of it, by the way. So enter an integer. So I'm going to put in a 1, 2, a 3, a 3. Notice 3 is a duplicate. Put in another 3. Well, it's already a duplicate. So let's go to 4, 5, 6, 7, 7. 7's a duplicate, right? And then when I'm done, I just blank line and we're done. I'm not doing a program complete on this one, but you could if you wished. All right. From here, we're going to move into exercise 4.3. And with exercise 4.3, by the way, it's another multi-parter. I know these guys kind of get a little bit tedious, and that's why I'm sharing code with you, so we can just move a little bit faster. And then I want you to hang tight if you want the answer to the other 2 exercises after we're done with this. We should be able to squeeze it all in by 10 o'clock. But if you have to go at 9:50, I totally get it. I'm not going to hold you here, but the solutions will be in the video so you can watch in the aftermath. All right, so this 4.3 is going to operate in very much the same way. So the first one is going to be to basically write a program that reads a line of input as a string and print only the uppercase letters, every second letter, et cetera, et cetera. So this time instead of working with numbers, we're going to work with strings, and we're going to use kind of that for each approach here. All right, so here's where I'm starting, and I'm sharing this code. Well, I didn't share the previous code in the chat. Well, here's the new code. It's the second box I just dropped in, and I'm going to put that in a new cell here inside the Jupyter Notebook, just so we have all the stuff here handy. And I guess I'm not sure what happened to A. Oh, A is, I got A here. I don't know why that didn't paste in. All right. So we're prompting for a string and capturing it. All right. And then we're going to go into a for loop. So the for loop's going to start like this. I'm going to say for each character in the input string, do the following. First, let's see if the character is uppercase. And I guess I haven't talked about this function here, but this is a function that is, and I should correct myself right away. This is not a function. This is technically what we call a method that operates on strings. And this is built into the string libraries in Python. This is kind of a de facto tool. And it returns a Boolean value of true or false. It checks to see if your string is uppercase. If there's any uppercase letters in it, it will resonate as true. So it's going to check, is the character an uppercase letter? If it is, right, then it's going to, we want to put it on the screen. So here's another little wrinkle that I'm throwing in here, that we're going to print that character, right? And then I'm going to add this special little formatting command that you can do in Python. This is kind of interesting. When I use this print command with this end parameter, what it'll do is it won't take the next print statement and put it on the next screen, like or one line down or on the next line. It will keep the output on the same line, so the letters will follow. Now, the directive here is only the uppercase letters should print, right? So it'll only print them if they're uppercase, right? Then I'm going to also throw in this little if statement here on this one. This is outside the for loop, by the way. So if the input string is lowercase, and mind you, we would say that here that we're looking at the whole string, not just the letter. So if there's no uppercase letters, it'll just say no uppercase letters. All right, let's run it and you'll see what I'm talking about. Enter a string. So let's do all lowercase. All right, let's run it again and say, it just found the T, right? Could run it again. Okay, so very kind of a simple little algorithm. Yes, I could put all of this inside of a loop and have it run many times if I wished, right? And I'm not going to do that engineering right now. We are going to work now on exercise 4.3b. The directive on that one is to display every second letter. So, and I'm just thinking here, I don't have to reprompt because I think this will stay in memory. I can just write an if statement to do this one. So I'm going to kind of grab this whole if statement with an else and just drop it in here. And yes, the benefit of being in class, folks, is I'm helping you with your work. Let's take a look at what this one does. Right. So if the length of the input string, I'm running the length function on this, is greater than 1. Okay, there's at least one letter. Then I run a for loop for I in range from 0 to the length of the input string. So I count how many letters there are in the input string. And I want you to think about this. If I have a 5-letter word, the first index position of the letters is 0. Then we go 1, 2, 3, 4, right? But the length of the string is 5. So the range of 0 to length of the input string will work and still give me the correct index number. And then I'm going to increment by 2 for I, and then that will be the index value of the string. Okay, this is kind of a weird one, I know. Let's run it. Now remember, I already typed in treat, and it took out the R and took out the A, and it just gave me T-E-T, every other letter, starting with the first one. All right, I'm going to move to another cell here. So for this one, we're going to check each character, and if it's a vowel, display an underscore instead of the character, right? So this time we'll reprompt, right? If you guys need that code, there it is, but you can copy it from yourself also. Then we'll do a for loop, and we'll say for each character in the input string, do the following, right? If the character is in this set of letters, notice A, E, I, O, U, and A, E, I, O, U, uppercase, lowercase, all of them, right? So if the character exists in that string, then let's print the underscore and keep it on the same line. So it's not altering the string, basically. Otherwise, we're just going to print the character and keep it on the same line. That you should be able to type in pretty quickly, I think. So I'm just going to go ahead and run this, and you can see what it does, right? So I'm going to enter a string, and what's it looking for? If it's a vowel, to replace it with an underscore. So I'm just kind of randomly typing stuff. And yeah, there's special characters in there. Press enter. Doesn't care about the special characters, right? So anywhere I had a vowel, it replaced it with an underscore. I don't know what utility this has, maybe for playing like Wheel of Fortune or something, I guess, right? Part D, and I'm trying to figure out what part D is here. That's not it. I think I put it in here somewhere, right? Oh gosh, I'm losing my place because there's so many cells. Oh, here. The number of digits in the string. This one's kind of an easy one, I think. So we're going to start with this code here in the chat. So I'll paste that in. So we'll get a string. We're going to set up a counter and preset it to 0. So this we're going to count how many characters there are. We're going to check each character, and if it's a digit or a number, and add it to the count, right? So that's kind of our directive. Here comes the for loop for this one. So same thing we did above. Oops, sorry about that. So for each character in the input string, if that character happens to be greater than or equal to, and notice this is the character 0. Now, there's a whole rationale behind this, and normally I would kind of lecture on it. But basically, we're looking to see if it's greater than or equal to 0, and if the character is less than or equal to 9. Now notice, in other words, if it's a number that's typed in as a string and it's in that range, then we'll count it, right? So then we're just going to take our counter and then plus equals 1 to it. If it's not a number, if it's a letter, it will ignore it, right? And then once we've done all that work, we don't need to do any output here. We'll just have an output at the end that tells us how many digits it contained. All right, let's run this. Right, so some letters, a couple of numbers, some letters, number 2, some letters, and there you go. The string contains 5 digits. Is that true? It is. And I want you to kind of see like past like just the mechanics of what we're doing here. is there a time where you might look at some text and see if there's numbers within it? And then you can do something with those numbers. Yeah, there might be code that you write that actually does that. So it's not an unuseful thing. Um, so with this last one, we are once again going to get some input, right? Then we're going to check each character. One by one. And then I'm going to paste all this in here, by the way. And if it's a vowel, display its position. Otherwise, not. Right. Okay. So we're going to do this with the loop also. And yes, I am copy pasting the whole thing because I am looking at the clock and we are now at 9:50 and I still have 2 exercises to go. So here's the completing code for this one. So for this one, we go from I in range from 0 to the length of the input string. And if the input string in that current position, we'll start counting at the first character, is in the set of vowels, then we'll print that letter, add a space, and keep it on the same line. All right, so let's just type in something snarky here. So the vowels are at position 2, 4, and 6. Be mindful of the fact that the first position is 0, 1, 2. So that one's 4 and that one's 6. You guys remember that. The first one is a 0. So that's all of 4.3. From here we go to exercise 415. This one I'm also going to kind of do, in kind of a hurry up fashion here, I guess. But I did want to talk about what the Fibonacci sequence is. If I can even type it here. Now I'll let AI kind of explain it, I guess, a little bit. So you can Google this yourself. But basically what the Fibonacci sequence does is it takes a series of numbers where each number is the sum of the 2 preceding ones. So when I add 0 and 1, it gives me 1. When I add 1 and 1, it gives me 2. When I have 2 and 1 added together, it gives me 3, and so on and so forth. And then you get like the sequence of numbers that kind of builds up, right? And somewhere, and I think the Wikipedia article does a pretty good job of it. They explain, like, they show you like the sequence of these numbers and how it's done. If you dig in here, they get into the mathematical proofs, and I know this stuff looks very hairy, but just don't freak out to it, basically. And they give the logarithmic proofs, and they go through this whole thing. And if I'm not mistaken, somewhere here they might even convert it into computer code. But ultimately, what I think is fascinating about the Fibonacci sequence is it describes the spiral of a nautilus. And it's a mathematical pattern that we see in nature. And this Fibonacci sequence is one that was identified a long time ago. And the ratio of like the one sum to the next is a ratio of 1.67 or something like that. And they consider that the golden ratio in numbers. All right. From a coding standpoint, how do we code this? And this one, yes, I'm helping you with this one, obviously, because this is probably not one you would come up with yourself, right? But what they ask you to do here is to get an input from your user. So we'll start with an integer. So we don't necessarily have to start the sequence at 1 is kind of the point. Because the first 2 numbers of the sequence can be problematic, we start with this if statement. So that'll be the first part of it. And this is part of the Fibonacci sequence. So if the first number is 1, we store that. Otherwise, if the number is 2, we make that the number that we're storing, but we're resetting it to 1 to do the calculation correctly. So we do an else if for that. And then from there, we run this code. And I am just going to drop all of it all at once, you guys, just in the interest of time. So that would come right down here back to the margin. So we would run an else. So once we get past those first two numbers in the sequence, then the sequence can go into its loop and keep developing that golden ratio. So we will basically capture the value, and the n that we're capturing up here is what number we're taking the sequence up to, right? So if you look at this Fibonacci sequence here, and you go back to the Wikipedia article where they have a little bit of an expression of it, like they take it up to, let's say, 144 here, right? So if I wanted to reach 144, I should type in 145, right? And then we can see if the sequence matches up. So I'm going to go ahead and do that. And I apologize for having to do this so quickly, but that's how it goes sometimes. You know. Here's the runtime. Let's put in a small number to start with, like 5. So if I take the Fibonacci sequence up to 5, it will total the numbers preceding it and give me 8. So the Fibonacci number of 5 is equivalent to 8. Let's try it again, and let's put in 145, right? Oh my God. Right? Not what I anticipated here, but the Fibonacci number that I put in 145, thinking it would cap out at 144. That's not what happened. It went through and it gave me 145 different values. And I want you to notice how big some of these numbers got, right? So keep in mind, in order to get to 21, I added 8 and 13. And in order to get to 34, I added 21 and 13, etc. So by the time I do that 144 times, this is the final number, which is the sum of this number and that number added together. And you could verify that. If you want to put it in a calculator or a spreadsheet and do it, go for it, right? But a couple very interesting things here, because this spiral will continue outwards at that ratio. How quickly it calculated it, and these were pretty large numbers. And this is one of those snarky things where sometimes I hit the run button on this and type in like a number like, I don't know, like a million or something like that, and it'll run a million times. And you might sit and wait for a minute or two, but it will do the calculation. I think that's pretty fascinating. All right, one more exercise to do here. This one goes pretty quick. Let's find the instructions for it. This is 418. 418 says, when I find it, write a program that prints a multiplication table like this. And I want you to notice a couple things here. First of all, the ... is not something you want to print. We're printing a multiplication table that shows, like, you know, the multiplication table from 1 to 100, basically. Like, so we'll have 10 rows and 10 columns. The ... simply implies there's stuff missing here, but there's row 4, 5, 6, 7, 8, and 9 before we get to 10. The one thing that's kind of interesting about this problem is, all right, I don't think it would be really hard to write a loop to kind of increment through the numbers. And even when we get here and we're counting by 2s, or counting by 3s, and then counting by 4s, counting by 5s, etc. The trick is to get them to line up like this and have the right number of spaces, so also allow enough space for the 100 at the end. This is kind of an interesting little problem, because the math part of it isn't so hard. I can do the math part without the formatting pretty easily. Now I am going to just straight up share this code. So once again, the benefit, here's this Fibonacci code. I forgot to hit send. This is all the code for the program that does this. And I think this is kind of crazy that it's so darn simple. And I'm just going to run this one. And which one was this? This is 418. So if you want to label it, I guess 4.18. So what this will do is this will run an outer loop that counts from 1 to 10, right? Never hit 11. And then an inner loop that runs also from 1 to 10, never hit 11. And then every time it does, I use these special formatting commands. And this basically, this little snippet right here forces the output to occupy 4 digits, right justified for everything that's output. Okay. The percent sign here is not a mod operator. It is the way that I take this calculation and insert it into that spot in the formatting formula. Right. And then we keep the output on the same line. So I want you to think about how this operates. So the outer loop's going to run 10 times. Every time the loop runs once, it will go to the inner loop, which will also operate 10 times. The first time around, it will take all the X's and the Y's. Now notice, the first time through, Y is 1. We get to the inner loop, it'll start with 1, so it'll be 1 times 1. The inner loop, X will increment to 2, 1 times 2, 1 times 3, 1 times 4, etc. When it finishes, it goes back to the outer loop, that becomes 2, and then we go 2 times 1, 2 times 2, 2 times 3, etc. And then outputs the table. Very, very small amount of code to create a multiplication table. So that's kind of the output here. I think it's kind of clever. Really kind of the major goal of having you guys do this here is to understand how the loops kind of work, right? So once again, the outer loop operates first. It does one iteration, starts with the number 1 in the Y position. Then the inner loop runs. That'll start at the number 1 for the X position. Every time it goes through, it does this math. And then it plugs the output of that math via the percent sign into this position, occupying 4 characters. So there's like 1, 2, 3, 4. Right? You can see it in the middle. And that's how we can get the 100 in there and still have a space left over. Now, we didn't spend a lot of time talking about these formatting commands, but I'm showing them to you kind of after the fact. This takes 4 numbers as digits and right justifies them, occupying 4 spaces no matter how big the number is. The end parameter here in the print command just keeps the output on the same line. So as I do the inner loop iteration, Y is 1, it multiplies by 1 through 10. The second time around, Y becomes 2, multiplies against the inner loop, 1 through 10, and it just keeps going until we get to the end. But don't you like how simple that code is? All right, it is now 10 o'clock. The exercises are now complete. So this video does end here.